water is being used to extinguish fire. But if you have hydrogen gas can actually react with the oxygen gas and generating fire there. Oxygen is necessary for any type of combustion. When you burn anything, oxygen is involved in there. So you can see what we are trying to compare here. Hydrogen molecule, oxygen molecule, water molecule. Water molecule is made of hydrogen and oxygen, but the properties are drastically different among these different three different types of molecules there. So you got to pay attention when elements combine together to form a compound. You end up with a different type of substance or matter, if you will, and that may have result in a drastic change in terms of their physical and chemical properties. Yeah. So that's something that we want you to pay attention to. And again, you can have hydrogen and oxygen gas mixed together in a balloon, and keep it in a dark place, please, and make sure you don't heat it up, otherwise you end up with an explosion there. So you can have a mixture there. Okay. You can also have a compound. The difference here is that these molecules are not chemically bounded together. The water molecule, hydrogen and oxygen molecule, hydrogen and oxygen atom are chemically bound together. So the molecule here is different than the molecule here. Okay. So that's the difference between a pure substance and mixture. Here we have a mixture, here we have a pure substance. And here you have two different types of molecules mixed together. Here you only have one type of molecule, H2O, mixed together, existing in this body of water there. Okay, so the chemical bound is what, word again, a chemical bound is what holds the molecules, atoms together. So we have what we call the compounds are composed of atoms held together by chemical bonds there. Okay, and chemical bonds result from the attraction between positive charge and negative charge. We know we have electrons and protons in each atom there. So when two atoms combine together, there's an attraction of the protons to the electrons and electrons to the protons there. There's also a repulsion there. So chemical bound in nature is the electrostatic, is the attraction in the electrostatic nature. So you always have that positive charge, negative charge, and attracting to one another, and that's what holds the atoms together. Okay. Now we have what we call ionic bound and covalent bound. We talked about ionic compounds in chapter 2. Okay. And ionic compound is the result of mainly metal and non-metal combined together. Now what happens to non-metal to non-metal? Say hydrogen, oxygen, both are non-metal. Carbon and oxygen, both are non-metal. You end up with water, that's a covalent compound. You end up with carbon dioxide, carbon monoxide, that's a covalent compound. Okay. So there are different types of compounds based on different types of chemical bound. And if you have an ionic bound, you end up with ionic compound. And if you have covalent bound, you end up with what we call molecular compound or covalently bounded molecules. Okay. So the difference in two different types of bounds. We will get into the details about the covalent bounding in chapter 8, chapter 9 later on this semester. Okay. And ionic bound we already know. It's a result of transferring of electrons going from one particular element to the other. Electrons going from the atoms of one particular element to the other. And so there is a transfer of electrons, there is a positive negative charge associated with the ionic compound there. Okay. So for ionic bound there, which occurs between metal and non-metal, or polyatomic ion, positively charged and negatively charged. Okay. And those are three possible combinations for ionic compounds there. It involves the transfer of electrons. Now, when metal interact with non-metals there, it can transfer one or more electrons to non-metal. So metal atoms, we mentioned this in chapter 2. Metal atoms will become positively charged. The term there is cation. The non-metal element will become negatively charged. The term for that is anion. So when you look at these terms there, you see a positive charge, you see a negative charge in there. So for ionic compound or for ionic bound, there's always a positive particle, positively charged particle. There's always a negatively charged particle. Okay. So in this case, whenever you have ionic bound present, you have an ionic compound. So ionic compound, as we mentioned in chapter 2, all of ionic compounds are solid at room temperature. There is no exception. And then also they are composed of lattice, a regular three-dimensional array of positive ions, negative ions arranged together in fixed ratio. NaCl, it's 1-to-1 ratio. You have a layer of Na and Cl, 1-to-1 ratio. You have another layer of Na and Cl and another in 1-to-1 ratio there. So with the alternating positive charge and negative charge. And that's the basic structure of the ionic compound. Okay. We are going to look into the details about covalent compound in another chapter there, but for ionic compounds, this is something that we want you to remember. Now, in terms of the covalent bonds there, and again, it involves the sharing of the electron. And again, how are the electrons being shared in covalent bond molecules? Well, we will get into the details about that in chapter 8, chapter 9 later on. But for now, the difference between ionic compound and covalent compound is that one involves the transfer of the electron, going from one phase to the other. The other involves the sharing of the electron. Okay? So the electrons are not completely transferred. For that reason, covalent bonded atoms compose of a molecule. You actually have the composing unit of that compound, like H2O. You do have 3 atoms clustered together by chemical bond. So you cannot separate them without going through a chemical change or chemical reaction. Okay? So we use the term for covalently bonded compounds there. We use the term molecular compounds to describe them. For ionic compound, if you take sodium chloride as an example, if you take sodium chloride, you put it in water, you end up with sodium ion, chloride ion. Those 2 ions are separated from one another, and they can move around freely. If you have sugar, glucose, you put glucose in water, you end up with glucose molecule. The 6 carbon, 12 hydrogen, 6 oxygen, they stay together as one unit. So that's the difference between these 2 different types of compounds there. Now, when we're representing compounds there, we use what we call a chemical formula. The element symbol would be, or atomic symbol in the periodic table, would be the alphabet for the language of chemistry. The compound formula, or chemical formula, or molecular model, and that would be the word in chemistry there. You're putting those different alphabets together in fixed ratio. Okay, just like when you spell English words there is a correct spelling versus incorrect spelling. Well, if you put the alphabets together in an incorrect way, then that's a wrong word. So water is spelled as, in the language of chemistry, H2O. Okay, and then carbon dioxide, CO2. Okay, sodium chloride, NaCl. This is how we write the word in the language of chemistry. So the formula is very important. The compound represents with its chemical formula. The chemical formula indicates first the types of elements involved in it, and also the number, the ratio, simplest whole number ratio among the different types of elements. So in this case, water H2O, that means for every water molecule, you have 2 atoms of hydrogen in it. You have 1 atom of oxygen in there. Okay? That fixed ratio cannot be altered. There's a joke. 2 guys walk into a bar. So the bartender asked him, "Oh, what'd you like to drink, sir?" And the first guy said, "Well, I want some H2O." He said, "Okay, I'll give you some H2O. What about you, sir?" And the second guy says, "Well, I'll take H2O too." So the second guy died, and the first guy survived. So H2O, that's water. You will have some H2O2, the hydrogen peroxide. Enough concentration of hydrogen peroxide, that's going to kill you. That's a very strong oxidizing